In this example, we're going to find the volume obtained by rotating the region enclosed by y equals to x, y equals to x squared about the x-axis. So very important is about the x-axis. And then they say use a Diggs or Washer method. Alright, so this is Diggs or Washer method. First thing, you need to sketch that region. So let's sketch it quickly. We know that y equals to x is just a straight line that passes through the origin. So that is y equals to x. And then y equals to x squared. We're going to have something that looks like this. Alright, so this is y equals to x squared. So this is the x-axis, this is the y-axis. Make sure you label your axis and label the graphs. And we know this is just going to be your region of interest. And notice it intersects at a certain point. How do we find the point of intersection? You just equate both graphs. X squared equals to x. Therefore, you have x squared minus x equals to 0. X into x minus 1 equals to 0. X is 0 or x is 1. So it intersects at 0, which is true because they both intersect at the origin. And this point here is just going to be 1. This is where they intersect again. And if you solve for y there, you just get 1. There we go. So first thing is to sketch the region. The next thing is to indicate the axis of rotation. This says about the x-axis. So you indicate your axis of rotation. And then draw a rotated piece that shows that it has rotated. So we're going to have something like this. So use dotted lines. There we go. So there's a rotated piece. It's about the x-axis. So you draw this rotated piece. Now notice it using Diggs or Washer. We're going to use a Washer method here because we're going to have some internal Diggs. Remember, we go surface to surface. Alright. So very important. You go surface to surface. Notice it. You have surface to surface there, and you have a surface to surface there. You have two Diggs. Alright, after doing this, you need to notice that you need to find the outer edges and the inner edges. Alright, remember that volume is just integral of area, and the area of a circle is just pi radius squared. In this case, we have outer and inner edges, so we should be able to find those. Now, notice it about the x, as we know we're going to integrate in terms of x, so our outer and inner edges has to be in terms of x. Let's look at the inner edges. The inner edges, how do we compute it? Is the distance from your axis of rotation, that is the x-axis, to the graph that it touches. So from there up to there. Alright? What is this distance? It's top minus bottom. It's just a parabola minus 0. So inner edges would just be x squared. Alright. Now let's look at outer edges. Outer edges is the distance from the axis of rotation, which is your x-axis, all the way to the line. Now what is the line? It's just x. That distance is top minus bottom, which is just x minus 0, which is just x. There we go. And therefore, we can find our volume, which is just going to be integral. We focus on this shaded piece. It's from 0 all the way to 1. Pi. We say outer radius squared. So outer radius squared minus inner radius squared dx. Alright. And if you do that, which everyone can solve something like this, you should get 2 pi over 15. Alright, so make sure you can integrate this and get that.